Here we're looking at 6 regular polygons: triangle, square, pentagon, hexagon, septagon, and octagon. And the question we're concerned with is, will these tessellate? Which means, can we tile with them? We're actually concerned about a regular tessellation. Can I take that triangle and make a tiling with just other triangles that are the same size and shape? Can I take that square and make a tiling with other squares that are of the same size and shape? So we'll start with a triangle. I'll remove the rest of these. And let's get some other triangles out here to see if they will tessellate. In other words, if we could make a tiling pattern with them. Could we tile a floor or a countertop with triangles? And boy, it certainly looks like these are coming together nicely without leaving any gaps or overlaps. Sometimes I push it a little bit with my fingers and it looks like there's a gap. But if I were able to place these, really, really smoothly and nicely, these would come together very well to tile. So yes, regular triangles can be used to form a regular tessellation. Next, let's take a look at squares. Let's get some squares out here. And I bet you can already guess as to whether these will work or not, but let's give it a try. Those could come together very well. And you've probably seen this all over the place on countertops or floors or ceilings. Squares are often used for tiling surfaces. So squares do form a regular tessellation. They can tile with themselves. So our next shape is a 5-sided shape, the regular pentagon. So here's our pentagon. 5 sides, all equal to each other, all angles equal to each other in this shape. And so we're going to bring some of these together and see if we can form a tiling pattern. So there are a couple of them. I'm going to bring in another one and see if it will fit nicely and snugly. And that really doesn't. It kind of leaves a gap on either side. I can maybe try to connect the sides here and then grab another pentagon and try to push it in here, but now the angle is too small, too narrow. So it's not possible to tessellate with regular pentagons. You're going to end up with some gaps or some overlaps. I could try to smash this on top or shove it in there, but it's not going to come together nicely to give me a nice flat tiling of a surface. So regular pentagons do not form a regular tessellation. So that's the 5-sided shape. Let's move on to the 6-sided shape, our hexagon. We're going to put some more out here. And let's see what happens as we bring these together. I have that opening, and look how nicely that fits. And let's bring in some others. Again, sometimes you see a little gap just because my finger jiggles it a little too much, but hopefully you can see that this really fits quite nicely together. I could put this here, I could put this here. Partly because the shapes I have are yellow, this reminds me of a honeycomb. So here we see a tessellation that actually shows up in the real world. Honeycombs are built of hexagons. So hexagons will tessellate, will form a regular tessellation. So moving up to our 7-sided shape, which is known as a septagon or a heptagon. Either of those words is used. Let's put these together, and then let's try to bring another one in there. And that also is not really going to fit. That's not going to come together. To be fair, a friend of mine cut these out for me, so they're not absolutely perfectly regular, but I think you can tell that even if these sides were absolutely perfectly equal to each other and all the angles perfectly equal, that this is just not going to work out. Which is probably why I wasn't able to purchase a perfect mass-produced set from a store. These things don't tile, and yeah, so they're just not out there for sale. So I had to have a friend make these for me. So regular septagons, regular heptagons will not form a regular tessellation. They will not tile. So one more, our last example is the octagon, the 8-sided shape, which we see every time we see a stop sign. So let's see if we can put these together. Boy, I don't know, that looks like kind of a narrow angle, and this looks like kind of a broad angle here. Am I going to be able to push one of those in and have it fit? And yeah, it looks like that isn't going to work. What if I connect it side to side instead of trying to push it into the angle? What we'll see is that actually you could form a really nice tiling using octagons if you also introduce a diamond shape or a square shape in the center. And that would be a tiling or a tessellation, but it wouldn't be a regular tessellation. What we're concerned about are regular tessellations, where the one shape we're concerned about would tile with other copies of itself. And that is not the case for an octagon. A regular octagon cannot form a regular tessellation.